Welcome, everyone. This video introduces our latest achievements from the Miro project, our new cloud-native orchestration solution. Miro is designed to simplify the management of Kubernetes clusters and deployment applications within the complexity of multi-domain, cloud-based environments. First, let's rewind a bit. In the past, applications were big, bulky monoliths. But times have changed, and we're in the era of microservices. Developers are now harnessing edge and cloud environments to create more engaging application experiences. However, the straightforward approach of a single cluster on a single cloud provider may not cut it anymore. Today, developers aspire to deploy their applications across various locations, including different clusters. These clusters may not be confined to the same cloud or region. They can span on different public, private, or hybrid providers. Yet developers don't want to get caught up in the infrastructure or intricate configurations. Instead, they dream of their components, seamless running and communicating regardless of their location. That's where the Miro comes in. It handles Kubernetes clusters and deploys applications seamlessly across multiple domains. Miro is a versatile cross-domain resource orchestration solution that brings the management primitives for bootstrapping and configuring a virtualized and container-based environment across multiple domains. The Miro system revolves around four key elements: a graphical user interface, GUI, a high-level orchestrator, a low-level orchestrator, and a monitoring system. The GUI lets developers define application components and requirements. The high-level orchestrator then uses AI to determine the best deployment strategy. The low-level orchestrator translates these decisions into real actions, setting up cluster and deploying apps using tools like Kubernetes operators and ETS's zero-touch. Finally, the monitoring system ensures everything runs smoothly and maintains seamless operations. The goal is to simplify Kubernetes cluster and app lifecycle management across a multi-domain environment, from creation to dynamic deployment. Now let's go through a series of demonstrations. Let's start from a blank state. No applications, no clusters. To create an application, we have several options to choose from. For now, let's choose from scratch. Creating an application in Miro is straightforward. Simply define its general characteristics, then visually compose its components, relationships, and requirements. In this example, we'll demonstrate how to create a Super Mario web application by simply defining its name and the properties of its single component. Miro allows the user to define and review all the properties of each component. This process includes specifying the image source, configuring settings, defining service endpoints, and setting requirements. These characteristics and requirements are then used in Miro's scheduling process to intelligently determine the optimal location for each component within the infrastructure. Once we're finished, we simply click the deploy button and the entire deployment process is automated. Miro provides visual feedback about the underlying process and all the steps being performed. Let's pause to review how scheduling works. Once we choose to deploy, the high-level orchestrator selects an appropriate AI scheduling algorithm, agrees on the metrics to use, and passes them to the algorithm. The AI algorithm then determines the optimal destination for each component and communicates the decision to the HLO. Let's return to the deployment process. Initially, no clusters were available, so Miro automatically initiated a request to create one. In the top section, we can observe the steps of the scheduling algorithm, where Miro gathers metrics, determines optimal locations for each component, and communicates these decisions across the infrastructure. Meanwhile, in the lower left, each step of the cluster creation process, including provisioning and setup, is shown. With Miro's automated handling of resource provisioning, placement decisions, and deployment, complex setups like this become simple and efficient, making it easy to manage and scale applications across cloud-native environments. Finally, the Super Mario application is successfully deployed in the Kubernetes cluster and ready to use. The deployment is complete, Super Mario is now live, and the cluster is fully set up. We can see details of the Super Mario application, including component endpoints, the application's geolocation, Kubernetes deployment specifics, and metrics for each component. With just a few clicks, the application is online and ready to play, highlighting Miro's efficiency and automation capabilities in cloud-native environments. This process demonstrates how easily Miro manages complex deployment tasks, making applications quickly accessible and fully monitored across infrastructure. Now let's see how to manually create a cluster. Just like with applications, creating a cluster only requires specifying basic settings: the name, data center location, and the flavors for both the Kubernetes control plane and worker nodes. In the terminal, we can observe the cluster being created in OpenStack through Cluster API. Cluster API simplifies Kubernetes cluster management by offering a declarative API to automate creation, scaling, and lifecycle management. It abstracts infrastructure complexities, allowing users to define cluster specifications consistently. By integrating with providers like OpenStack, Miro enables seamless provisioning and management. This streamlines Kubernetes operations, enhancing scalability and efficiency. At the end of the process, we can confirm that the cluster has been successfully created. The cluster is then visible in both the Miro dashboard and the OpenStack web interface. Now let's go to a more complex deployment scenario. Next, we'll create an application using a template, a cat versus dog voting app. We have not only additional components to deploy, but 2 clusters now in place. The template option allows us to quickly design an application using pre-configured settings. Once the application definition is complete, we simply click to deploy it. AI will determine which cluster should host each component. After deployment, we can view the distribution of components across the 2 clusters, along with the details of each. We can now access the application and vote for your preferred option and see the results. I prefer dogs. For the scheduling, the AI algorithm carefully analyzed each component's requirements against available cluster resources. Step by step, Miro collected metrics to decide optimal locations for each component across the network. In this case, Miro not only determined the optimal locations, but also dynamically peered the 2 clusters based on the application definition. This automatic peering allows developers to seamlessly leverage multi-cluster setups without having to worry about inter-cluster connections. In the end, we can see the application components successfully distributed across both clusters. Miro dashboard also provides an overview, displaying graphs for various metrics across clusters, offering a clear view of the infrastructure's resource distribution. That's it for today. Thank you for your attention.